Assalamu alaikum everyone. Today we are having sixth lecture for CS116 object oriented programming. So let's get started. Okay, last time we saw how we can define simple classes, how we can instantiate simple objects, how we can document these classes, and we did a lot of coding examples, and I hope you did all those practice problems by yourselves and now you are pretty much clear about the concept. Today we'll see what happens behind the scenes when you define a class or you run a code or you instantiate objects. And we'll use that means that we'll study the concept of namespaces today, and we'll use this concept to define or to differentiate three types of variables that exist in a class: instance variables, class variables, and local variables. Now, before moving on, let's recall some concepts from last semester that will help us understand today's lecture better. First is the concept of object and variable names. Let's suppose I write this statement: x is equals to 3. In this statement, 3 is an object and x is merely a variable name or a handler linked to this object 3. So when your program runs, what happens? Your system allocates memory for 3, and x is just a handler for this, right? Now let's suppose I define another variable name y and link it to the same object 3. So your system will not define a new object 3. What it will do, it will create this new label and it will link it to the same object 3, right? And now if I want to reassign it to some other value 4, now 4 is a new object now. So a new object will be created, this previous link will be broken, and now it points to this new object 4. So now y is equals to 4. See, so my point here is that object carries all the weight, and variable name is just merely a handler for some object. That's why we were not able to define those attribute names without initializing them to some concrete object. Second thing which I want you to recall is namespaces for functions. Let's suppose I define a function add, and it takes two values and it simply returns the sum of these two values, right? Now if you call when you call this function in your code, for adding two numbers, what happens? A namespace is created for this, and if you are defining any variables, they are defined within this namespace. And if you call this function again for some other values, that means a separate namespace will be created. And the lifespan of this namespace is equal to the lifespan of this function. Like this namespace exists as long as the function lives, right? And these namespaces, they are independent of each other, they do not interfere with each other. That's why we were able to implement that concept of recursion, right? Okay, today also I'll continue with my favorite animal class example. This is the simple code that we had been using in the last class. We defined two attributes here for this class animal, and we initialized them to these two values cat and mew, and then we defined three simple functions, right? Three simple methods, and two of them, they are setter methods, and the last one, it simply prints a string using the attributes of the class, right? And here's a small code which is really easy to understand. In the first statement, I'm initializing an object of class animal, and I'm calling it A1, and then I'm calling two setter functions for this object A1. One is setting species to mouse, and the second one is setting the attribute language to squeak. And the last one is A1.speak, which will print these attributes on screen in the form of a complete sentence. So this is the output of this. I hope you won't find it difficult to grasp. Now, today we'll see if when this code runs, what happens at the back end. Now let's see what happens behind the scenes when this code runs. So whenever you define a class definition, what happens? Your system creates a namespace for this class. So this is the namespace that has been created for this class animal. It just contains the handler for all the attributes and methods defined in that class. So we define 2 attributes, species and language, and 3 methods, set species, set language, and speak, right? Now this is the class blueprint, right? As we used to call it in the initial lectures. Now the problem here, in fact not the problem here, but Python enforces you to initialize these attributes. You simply cannot write the attributes species and language without initializing them in a class. So these cat and mew, they are actually string type objects. So your system will create these objects in memory, right? And then these objects, they'll be linked to these 2 variable names, species and language, which are actually the attributes of our class. So this is the scene when you define a class. Now let's start running that test code. Now let's run the test code. This first statement, a1 is equals to animal followed by those round parentheses. It will instantiate an object a1, and whenever an object is instantiated, a separate namespace is created for it. So this is a separate namespace, and you see here this separate namespace, it holds a different set or a separate set of those attributes, species and language. However, the code for the methods, that resides with the class blueprint only, right? We'll see shortly how that code executes. So a1 object has its own set of attributes, and they are initialized to the same objects because we have not initialized them or reset them to any other value. Now when you call this method set species, what it is supposed to do, it is supposed to reassign that attribute species defined in the namespace of a1 to a new value, which is mouse in this case, right? So what happens when you call this method, say, as I told you that the code will be executed from the blueprint. So a separate namespace is created for this method, and you see that handler a1 dot, that helps the method to identify which attribute or which set of attributes it has to use. Like you see, species and language, these are the attributes which are defined in 2 namespaces, one in the animal namespace and the other in the objects namespace a1. So this a1 actually, it helps us, a1 dot, this handler actually helps helps idle to choose the correct pair of attributes. And how it happens, actually it happens because of that special word self that you used in the code. So wherever you used self dot identifier, that will get replaced by a1 dot. So if you are accessing within this method, if you are accessing self dot species, that will now become a1 dot species. So this method will access self dot species, which is actually a1 dot species, and it will reset it to the value mouse. So this is what will happen. The old link will be broken, and now a new object has been created called mouse, and now species of a1 points to this value mouse. However, the old species or the species attribute defined in the class, it's still pointing to that same old object cat. Similarly, when you call, okay, after this method finishes, the namespace is gone. We all know that. Now, if you call this second method set language, it will do the same thing, but with that second attribute language. So a namespace for this method will be created, but now this method will be called with this a1 handler. So all the self dot terms in the code of this method, they'll be replaced by a1 dot. So so self dot language would mean a1 dot language in this case. So language will be now pointing to a new value. Language of a1 will be pointing to a new object squeak, right? Okay, after this function finishes, that namespace is gone. And now we are calling this third method a1 dot speak. Now when this is called, again a separate namespace is created, right, with this handler a1 dot speak. Now this method, it does not define any new objects. It is just accessing those objects already defined, and it's printing something on screen. So a1 dot will make sure that the attributes accessed by this method, they are from the namespace of a1, right? So it will access a1 dot species and a1 dot language. Now after this function or this method finishes, let's define another object of the same class, a2.animal. And when you do this, what happens? A new namespace is created for this object a2. Right now you see we have three namespaces, one for the class, second is for first object a1, and the third is for uh, a second object a2. Now one thing you should notice here, that a1 still exists. Although we saw with the methods that when the method is over, its namespace is gone. But here, this object a1 is still exists at backend. And we'll see later that there are methods by which you can destroy it or you can delete an object. Or when your code finishes, when your program ends, then these objects, they gets destroyed. But if you are not deleting them, explicitly, they exist till the end of your program. So a1 is still there, and now we are creating a new namespace for a2, and it has its own set of speciation language, and obviously they are initialized to the same those objects cat and mew. Now let's call a function for this, set species. Now this will reassign this species of a2 to lion. So what will happen? First, the namespace for this method will be created, and now it is with that handler a2 dot. So all the self dot terms in that method, they'll get replaced by a2 dot. So it will access a2 dot species and it will reassign it to lion. So lion is a new object, and now species points to lion. So that's how your code will work at the backend. Now let's define some types of variables here, or some types of attributes here. You see three namespaces exist here. Let's suppose your code has not exited yet. So three namespaces exist. The first one is for the class blueprint animal, the second one is for object a1, and the third one is for object a2, and each of them have these attributes, species and language. So the attributes, when you define them in a class blueprint or in a class definition, they are called class variables, right? And when the same attributes, they are defined in namespaces for objects, they are called instance variables, right? So the attributes, species and language, when defined in a1 and a2, they are termed as instance variable because they are defined in instances of that class or in objects of that class. And species and language defined in main class blueprint, they are called class variable because they are defined in that class, right? And we'll see that both of them, they have their own advantages. We'll see that shortly. Now let's add one more method to the same example. I'm calling this method speak a lot. So this is the code that we have written up till now, and I'm adding another method speak a lot. Now what this function does, it simply prints that attribute language 5 times. I think you are all able to make out what's happening in this simple loop. I am using a loop, for loop here, which starts from 0 to 4, right? I's value will keep on changing, and that will count the iterations. And then in each iteration, which what we are doing, we are simply printing that attribute language, right? So that means if language contains mu, then mu will be printed 5 times, right? Now one thing that I want you to appreciate here is that, see this at this counter for loop I am not using that identifier self dot with it. It is just written as it is I, whereas with language I am using this identifier self dot. Now let's see in this example how this works at the backend. Now before proceeding to that, let's use a small test code and see what happens when we call this function. So here I'm initializing a new instance called a1, then I'm resetting that species attribute to mouse, and then I'm resetting language attribute of a1 to squeak, and now I'm calling this function speak a lot. So this speak a lot is basically printing something, so it will produce output on the screen, and what it will do, it will print it will print squeak 5 times, right? Because that's the language of a1. So this is the output, okay, what we expected. Now behind the scenes, what's going on? First, namespace for class will be created. Objects, species and language, objects cat and mew will be created, and they'll be linked to those attribute name, species and language. And when you start running that code which we saw on or that test code which we saw on the last slide, first we are instantiating a new object a1. This will create a separate namespace with separate set of attributes. Then initially they'll point to the same objects. Then so this is what will happen. The old link will be broken, and now a new object has been created called mouse, and now species of a1 points to this value mouse. However, the old species or the species attribute defined in the class, it's still pointing to that same old. So this method will actually reset species of a1 to mouse. Okay, then this namespace is gone because that method has ended. Now comes the second method, and it works the same way. Now if you call this second method set language, now I'm calling this third function speak a lot. So namespace for speak a lot will be created, right? Now you see that variable I, since you are not accessing it with self identifier, so that means it is not a class attribute, or it is not an attribute of any object, right? It's just a simple variable that is created within this specific method speak a lot. So it's a local variable to this method, right? So if you recall from last course, when local variables are created in a namespace, they live as long as that specific namespace lives. So this I resides in this new namespace, in the namespace of this method speak a lot. Whereas species and language, they when you instantiated a1, they resided in the object's namespace. And even in this function speak a lot, whenever you access species, since you are accessing it with that self dot, or in other words a1 dot, that means that you are accessing those attributes from the namespace of a1. So the difference between I and self dot species or a1 dot species is that I is a local variable which is local to this method speak a lot, whereas self dot species is not a local variable for speak a lot. Self dot means that this method speak a lot has to get it from the namespace of class. So I is called a local variable, and it is different from the other variables, species and language, defined in the other namespaces. Now we have three types of attributes or variables here in this same scenario. Species and language defined in that class, in animal class blueprint, they are called class variables. Then we define same species and language for this instance a1, they are called instance variables. And this I is defined within a method, and it is called a local variable. And how your system distinguishes that it's a local variable? Because you have not referenced it with that self dot identifier, right? So that means it's a local variable, and the lifespan of this I is equal to the lifespan of this method speak a lot. So when this speak a lot method finishes, this I is gone. However, class variables and instance variable, they are still there, right? So instance variable, they stay as long as the object stays, and since we haven't seen any way to remove these objects other than finishing your program or exiting your program, so these species and language or the instance variable, they will live as long as your program runs, because objects are there, right? And those class attributes or class variables, they always run as long as your program runs, right? Now, there was a small problem in the last code, and not a problem, but something we did was not really useful there. Like, you see, we initialized these class attributes, species and language, to cat and mew, and they were good for initialization purpose, like they initialize the objects to these values too. But apart from that, these cat and mew, they were useless, right? Like these class attributes, we never access them, but we can access these attributes and they can be of use in certain scenarios. So this example in which I am adding another method here, count animal, will show you how you can access a class attribute in your code and how you can make use of it. So for that purpose, I am adding another attribute here, count is equals to 0, right? So now your class has three attributes: species, language, and count. So this is the old code. I'm not showing here getter, setter, and speak methods because we won't be needing them here in this example. So the code is still there, right? So speak a lot, there we saw a local variable I, and self.language means that we are accessing an instance attribute, right? Self.language means that it's going to be the instance attribute for the instance for which we are calling this method. Now let's define this new method, count animal. Okay, this count animal is not taking any argument from the user, so self is the only essential argument there, right? Now you see the first statement is animal.count. So the different thing here is that I am accessing an attribute count of this class, but I'm not accessing it with that self.handler. Instead, I'm accessing it with class name. So if you want to access any class attribute, what you do, you access it with class name, right? So now we have you see a new difference between these three types of variable. Whenever you access an attribute from an object's namespace, or in other words, whenever you are accessing an instance variable or an instance attribute, you access it using that self.handler, right? And whenever you want to access some class attribute or an attribute from that namespace of class blueprint, then you access it using class name. So class name followed by a dot operator, and then you write the name of that attribute, right? So animal.count will not access count from the namespace of any object, but it will access this count from the main namespace, the namespace of that class blueprint, right? And I is the third one, and since we are not accessing it using any self dot operator or class name dot operator, so that means it's a local variable and it will reside as long as that method resides. Now if you see what this method does, this count animal method does, it's simply incrementing that class variable count. And why I'm saying that it's a class variable, because it is accessed with that identifier animal dot, right? So it will simply make that count, it will simply increment that count, right? Now before moving on to the test code, let's identify the three types of variables in this code. Now you see I is a local variable. There is no question about it. I is a local variable because it is not accessed with any self dot identifier or class dot identifier. So it's a local variable. Now, if we come to class variables, that is simple. Those three variables at the top, species, language, and count, they are defined for the class within a class, and they are all class variables, right? And if you want to access them, you have to access them using that class dot identifier. Now, judging that which of the variables are instance variable, that's a little tricky. You see, here we are defining three attributes: species, language, and count. But out of these three attributes, only species and count are the attributes which we are accessing within the code using that self dot identifier. We never accessed count using self dot identifier. So that means when a namespace for that for any object is created or for any instance is created, that will contain only species and language as attributes, and count will not be there because count has not been accessed throughout the code using that self dot identifier. So this is an important point which you should keep in mind, that count only exists in the main namespace, whereas species and language, they exist in all the namespaces, in classes namespace and in objects namespace as well, right? Now let's run some test code, and I encourage you, in fact, I expect you to visualize the backend scenes in your heads. Okay, I'm instantiating an object A1 here, and by this time, when I have instantiated this object, that means now two namespaces exist at backend. One is for the class blueprint, and that namespace will contain all three attributes: species, language, and count. And second namespace will be for this instance or for this object A1, and that will contain only two attributes: species and language, because count is never accessed using operator in the code, right? Now a1.speak, it will invoke this method speak using this a1 operator. That means all the self dot terms will be replaced by a1 dot term, and we expect the output, since we have not reset these attributes species and language for a1, so it will produce this output: I am a cat and I can mew. Now let's call this function count animal. Now, although I'm invoking it on a1, but since if you see the code of this method, there you are accessing that count attribute, and since you are accessing it using that animal dot, that means class's name, that means you are accessing it from the main namespace or the namespace of the class, right? So it will make this count variable or increment this count variable from 0 to 1, and that will be returned by this function, by this method, and it will print it on the screen, right? Now let's define another object a2, and we are initializing it to two different values. Obviously they'll reset species and language of this namespace a2 to dog and bark. So if I call this function speak, I expect it to write the same sentence: I am a dog and I can bark. Now if I invoke this count animal method on a2, now this method is again accessing the same count, the class variable count from class's namespace. Previously it was set to 1 by a1, and now it will be incremented again, and now its value becomes 2. So I expect the output to be animal count colon 2, and that's what it is, right? Okay, I'll show you more examples on this, but before moving on, let's quickly recap what we have seen so far. That might help you clear some of the confusions. I told you that whenever you define a class, when it executes, a new namespace is created for that class. And whenever you instantiate an object or objects, more than one objects, then for each object, a new separate namespace is created, right? And whatever attributes you define in a class, a copy of those attributes, they exist in each of these namespaces. Then whenever you invoke a method on an object, a new namespace is created for that method, and this namespace stays as long as that method runs. When that method finishes, this namespace is gone. Okay, then we saw three types of variables. Instance variables or instance attributes, they were defined in an object's namespace. Then class attributes or class variables, they were defined in a class's namespace or the blueprint's namespace. And then we had local variables, which were defined in a method's namespace. Now let's compare them side by side. If you want to access an instance variable, what you have to do, you access it using that self dot operator, right? And that self is then ultimately replaced by the name of that object, right? So if you want to access in your code or in any method, if you want to access an instance variable, you always use that self dot identifier. If you want to access a class variable, you access it using class's name. As we saw in last example, that count was accessed using animal dot operator, and animal was the name of the class. And if you want to access a local variable, you just access it without using any identifier, like it is accessed as it is without any handler. Okay, then about their lifespans. An instance variable lives as long as the object lives, right? Whereas a class attributes lives throughout your program, and a local variable lives while your method is executing. When the method is finished, that variable is gone, that local variable is gone. And the last point is about shareability. An instance variable is only visible to that particular object because you define these instance variable uniquely for each object. So an object can access only its own instance attributes or variables. So instance variable, they are visible to that object only for which it has been defined, or in which name in whose namespace it resides. Whereas a class attribute, it is visible to all objects, right? You can access a class attribute from any of the objects. It will be accessing the same copy from the class blueprint. And local variable, it is not shareable. It is exclusive property of just one method, or one instance of a method, right? Now let's see a comprehensive example. I want to make certain changes here. Okay, this is the part of code that I'll keep from the previous slides. Like all the methods up till speak aloud, they are the same. Now what I want to do here is, I want to keep count of the total animals. That means how many objects I'm instantiating, I'll keep the count of that. And also I want to assign a unique ID to each animal. For example, I instantiate first animal A1 and make it, let's suppose, dog. So I want to assign this dog an ID of 1. Then I want to instantiate another animal, let's suppose A2, and I name it lion, and I want to assign it an ID 2. And then I instantiate a third animal, let's say a mouse, and I want to assign it a unique ID 3, right? So I want to assign different IDs to each animal, right, as they are defined. And I also want to keep track of the total count. Since I have defined or initiated 3 animals, instantiated 3 animals, so total count should be 3, right? So let's see how we can do that. I'll alter that method of count animals a little here. Okay, now let's define a new method here, assign ID. If you see this method, it takes 2 arguments, the self, the essential one, and a small id. Small id means it's going to be a value that we'll assign to that animal, right? Value for id. So there is just one line in this method, self.id is equals to small id. Now this self.id, it is going to be an instance variable because I'm accessing it using self.operator. Although I have not defined this variable capital ID in those attribute lists at the start of the class, but since I am accessing it using self.operator, that means it's going to be an instance attribute, and we'll see more on it a little later. Now what this method will do, it will simply assign this small id value passed by the user to this instance variable id, right? Now this is another function that I have defined. It might come handy at some time. Okay, now let's tweak that function count animal. Now what I want to do here is, what I'm planning to do here is, we use this function to count the animals. So what I'll do, I'll use that count value to be used as ID for that particular animal. For example, for animal number 1, count will be 1. So 1 will be assigned as ID to that object. Then for animal number 2, count becomes 2, and that count will be assigned as ID to the second object, right? So let's do that. Okay, the first statement, it's accessing this class attribute count. So animal.count plus is equals to 1. That means this class attribute count will be incremented here, right? Now this count value, I'll assign it to that particular object for which this count animal function has been called. So what I can do, I can call this method self ID. Now you are calling this method specifically for that instance. So you call that method using this self operator 2. So this is something new which we have not used so far. So if within a class, if you want to call one method from some other method, that method has to be called using that self.operator. So I'm calling this function assign id using self.operator, self. self dot assign id, and then I'm passing this animal count value as value which has to be assigned to self.id. So this animal count id will be mapped to that small id over there in assign id method, right? I'll show you the working also. Just wait a little. And then this is the previous line, return animal dot count. So I've just added one more line in this method count animal. What it does, whatever count it comes to at when this method is called, that count is assigned as id to a particular animal, right? I'll run this code for you, but before doing that, let's identify the three types of variables in this code. Now, this is the list of class variables: species and language and count. And these are class variables because I have defined them explicitly at the start of that class, right? ID is not a class variable because I have not defined ID here in this list explicitly in the class. ID is only used with self.operator within a method. So ID is not a class variable. Now let's come to instance variables. Now instance variable, species and language are instance variable because they are being used using self.operator in various methods. Count is not an instance variable because we never used it in the code using that self.operator. But ID is an instance variable because I'm using it using that self.operator in assign ID method and in get ID method too, right? So see, there is a difference between count and id. And local variable, there is only one local variable, that is I, which is used as a counter in speak a lot method. Now let's run this code. Now at the start, what happens there, one namespace exists. This is the namespace of class blueprint, and it contains these three attributes, and we initialize them to cat, mu, and 0 respectively, right? Now let's run this statement. A1 is equals to animal. It will instantiate a new object A1, so that means it creates a new namespace. Now this instance variables namespace will contain three variables: species and language, initialized to cat and mu, but id has not been initialized yet, so it does not contain anything yet. Actually, we cannot access it until or unless we call that function assign id. We know this problem exists. We discussed it in previous slides. Then I call this function count animal. Now this count animal method, sorry, not function method. This method does two things. It increments the count value, right? And that count is actually a class variable. So count from class variable will be incremented to 1, and that 1 will be assigned as id to instance variable in A1, right? So when it will execute, this will be the new situation. Count has been incremented to 1, and that same value has been passed in as an argument to assign id and has been assigned to this instance variable id, right? Now let's instantiate another variable A2. That means it will create a new namespace, okay? And now if I call this function again for this attribute, sorry, for this object A2, what I expect to see is that again this count, class variable count, will be incremented and it will make its value 2, and that 2 will be assigned as an id to instance variable a2.id. Okay, so this is what it does. Then I instantiate a third object A3. Same thing happens. Count is incremented to 3. Okay, a new namespace is created first, and then count is incremented to 3 when I call this method count animal, and that 3 will be assigned as id to this third object A3's id, A3.id, right? So this is going to be the scenario. Count is now 3, and this 3 has been assigned to the id, which is an instance attribute for A3. Now let's add some code to print something on screen. So let's print these instance variables and class variables and see what they show. So this is the first statement. See, this is accessing that attribute count, and it is accessing it using that animal dot specifier. So it will access the first namespace of class variables, and I expect to see a 3 at the output. Okay, so here we have that 3. Now let's suppose if I want to access that ID for instance variable a1, I'll call its function getID. GetID will return me this ID instance variable from the namespace a1. So I expect to see a 1 here. Okay, 1 it is. Okay, I'm checking again animal count. Does it change? No, it doesn't change. It's still 3 because it's picked from the same main blueprint class variable. Get ID, this will, since it is invoked on instance A2, so it will get instance attribute ID from namespace A2. So I expect to get a 2 here. And same is the case for the third animal, right? So here we see that we have assigned separate IDs to each animals, and this count class variable is keeping track of all the instances that I have instantiated here. Okay, this is again just a check, and it prints this 3. Okay, here's an exercise for you. You'll use the same class that we defined on slide 11, and you'll run this test code for it. Actually, you won't run it on idle, but I want you to run it on paper. Like, try run this code and try to think what output will it produce, right? And then you can run that code on idle and you can match your answers, or we can discuss these outputs in the live session, in the next live session. So that's it for today. This is what we did today. We saw the concept of namespaces for classes and objects. We discussed these 3 types of variables in a class: instance attributes or variables, class attributes or variables, and local variables. And we saw how they differ from each other in terms of namespace, lifespans, and visibility. Thank you.